So the second presentation will be given by Shiva Sundaram from TWI in UK, and the presentation will be about the project HIPIN. I don't know if I pronounce well. It's more or less about nanostructure material. I don't know the project, so I am very looking for the presentation, forward for a presentation of Shiva.
Thank you, Daniel. Good morning, everyone. I'm here to present a high-performance insulation based on encapsulation of air. It's a HIPIN and pronounced very well. I'm from TWI. I'm the scientific coordinator of this project, and TWI is an organization, an independent organization in the UK, doing a contract research work. And HIPIN is a collaborative project funded by FP7 and MP program, and it's a 3-year duration, started in November, so we are almost in the mid of the year project. And we are 9 partners, a mix of both RTDs and small SMEs and big companies like ExxonMobil. In this project, our main aim is to develop a nano-based high-performance insulation system for energy efficiency, and we are looking at introducing silica aerogels into common building materials. And as Unit has already explained a lot about aerogels, we have chosen silica aerogels mainly because of its lowest thermal conductivity and low density and lowest refractive index, and good sound insulation, and it has also got fire retardant properties. But aerogel is basically just the encapsulation of air using various matrix system. And in this project, we are looking to develop an affordable technology to introduce aerogels into a suitable vehicle that could be applied easily onto building. We are looking at common building materials such as paints, plasters, or sandwich panels like insulating blankets. The main challenges today are that aerogels are highly fragile. Even for a touch of a hand, the aerogels can break, and it's highly expensive. And also to check on what choice of aerogels are available, either hydrophilic or hydrophobic, what density to use, and what catalyst of aerogel to use. So there's a series of a range of aerogels available, and also to the adhesion or the compatibility of the aerogel with the matrix system, such as paint or the plaster or any other building materials, can be complicated, and to choose the right formulation and matrix system. So in HIPIN, we are addressing to develop a robust aerogel which is mechanically strong enough to withstand the mechanical force, and modify the process route the way the aerogel is made so it can bring down the cost. And we are also functionalizing the aerogel to adapt to the matrix system. And to have a good compatibility with the matrix system, we are doing surface treatment on the surface of the aerogel, and we are looking at characterizing and optimizing the formulation for better thermal performance. As a first objective, we have developed a robust aerogel by developing a high silica content precursor. Precursors are normally used to develop the aerogel. And high silica content translates that the aerogel walls are made thicker and easy to handle, therefore it can withstand the mechanical force. And we have successfully achieved up to 60% of silica content precursor. We are also looking at introducing multifunctionality to the aerogels to make it hydrophobic or hydrophilic or fireproof or any properties that's required. So initially, to start with, we have introduced hydrophobicity to the aerogel by introducing functionalized Stöber spheres, which was synthesized by TWI, and we are looking at patenting this, and we are investigating on that. Stöber spheres look like that, but we are also introducing multifunctionality by adding organic groups to it. The main advantage of introducing Stöber spheres is being a silica microspheres. We also reinforce the aerogel wall, but the drawback is that we are having a loss of opacity, as you can see in the picture. And hydrophobicity becomes an important property for our project to introduce into the aerogel structures, because if we try to introduce aerogel into a paint system or plaster, the aqueous or the water system can enter into the pore structures, which means it breaks the encapsulation of the air. So we want the aerogel to be hydrophobic, so it doesn't allow the water to enter the pore structures. So this shows an example of the standard aerogel dropped into the water. It sinks, and the HIPIN aerogel is able to float, so it's hydrophobic. And this is our recent results from the project. There's a choice of aerogel you can achieve by varying different parameters during the processing stage, either by varying the density, the pore structures, making it hydrophobic or hydrophilic, and various other properties can be varied by changing the catalyst or doing a surface treatment. So we are looking at choosing the right aerogel to be incorporated into paint and the plaster or the panel system. And the characterization is being done by using contact angle measurements to measure the contact angle between the water surface and the aerogel surface, to measure whether it's a hydrophilic or hydrophobic and the degree of it. And we are looking at measuring the pore structures by using BET analysis system. And one of the main objectives of aerogel is to make it robust. So we are measuring the hardness and the robustness between the standard aerogel and the HIPIN aerogel using nano-indentation. And we are looking at the pore structures by using the same characteristics. Incorporation of aerogel into paint or a plaster or the panel system is not so straightforward because of the complication we could face in the having a compatibility issues, and it becomes even more complicated because of the hydrophobicity that we have introduced in the previous stage. So therefore, we are looking at introducing a surface enhancement to the surface of the aerogel. So it becomes the choice of the surface treatment will be made as suitable to incorporate into the paint or the plaster or the panel system by identifying the right polymers and the solvents and varying the deposition parameters. So this will allow us to have a good compatibility with the matrix system. As a first result, by incorporating aerogel into the paint, in the first stage we tried to introduce a hydrophobic aerogel. It shows that it's a suitable sheen profile, but the hydrophobic nature of the aerogel causes it to agglomerate or causes bits on the dried paint film, which is not ideal for a decorative paint. So therefore we looked at the hydrophilic aerogel system. This is a comparison between the standard paint and the HIPIN paint, which has got hydrophilic aerogel in it. As you can see, there's a smooth finish in the standard paint, but HIPIN paint has got still a small bits, but much better than the hydrophobic aerogel, which has got agglomeration of paint. So we are still working on it to make it a smooth finish. The wet and the dry paint properties look encouraging, and we have got, but except for its low shear viscosity profile. We are still investigating on the insulation properties by varying the different thickness of the paint. But as Daniel mentioned earlier on, thickness of the paint is very minimum, so we can't really expect a tremendous energy efficiency. So we are looking at to combine with a plaster system or the panel system together, so as a complete system it can make a good energy efficient product. And incorporation of aerogel into plaster, there are challenges can be faced in 3 different stages, either while dry mixing stage, or while mixing water, or pumping application while in the application stage. It can cause mechanical damage to the aerogel, so we are quite careful, and that's where the surface treatment on the aerogel helps us. We have formulated various products by varying the percentage of aerogel, binder, or aggregate system, and varying the additive percentage, and also trying different types of them. The best formulation we have achieved has got a lambda value of 39 plus or minus 5% watts per meter Kelvin, and this was measured according to the standard of EN 12667. We are still working on to make a better performance formulation, and we are trying different options. But so far, we think this is the best available product in the European market. But we still have to work towards it to make it much better before we introduce this into the market. And final product that we have looked at is to introduce aerogel into panels. The aim is to reduce the thickness of the insulation blanket, which is currently 9 centimeter thickness, into an insulation panel of about 3 centimeter. The idea is to introduce the aerogel granules into expanded polystyrene, either at the molding stage or various stages. So we are successful introducing aerogel into expanded polystyrene during the molding stage. We have made a cake out of this. So this is shown, the feasibility is proved, but we still want to investigate this, whether the aerogel structure is affected during the processing stage, and if the thermal conductivity is better or not. However, the final product disaggregates, and on the surface it's a bit dusty, but it's not as bad as a space loft aerogel product. So this is where the surface functionalization becomes imperative, and we still have to investigate on various formulations, and finally we would like to look at the production stage and processing, where the mixing and cutting of polystyrene with aerogel becomes easier, so it can be easily introduced into the market. Once we have the final formulation of all the 3 products, we are looking at demonstrating it in a building where we would like to maintain a temperature difference of 10 degrees Celsius and have the windows and doors closed and heated environment of 24 hours a day. The conclusion of so far is that we have successfully achieved a robust aerogel and low-cost aerogel. We have managed to introduce multifunctionality, so we have a series of aerogel with a degree of hydrophilicity and hydrophobicity. And we are able to introduce HIPIN aerogel into paint, plaster, and panel system, and we are currently investigating different formulations of this, and we would like to achieve a better performance product and measure the thermal performance on real building as well. Thank you. Any questions, you can write to me in this email ID, and also check on the HIPIN website. And we are also part of the nano cluster, so we are looking at the various dissemination activities together. Thank you.